Hi, I am Khalid Shalabi. I will be giving you introduction to mechanics. So at first, what is mechanics? What are we going to study in this course? Is it about studying chemical reactions, electrons and bonds and this stuff? Well, no. Is it about studying words and meanings? Well, no. Is it about studying insects, living organisms? Well, absolutely not. Simply, the answer is it is about studying objects. Either they are moving, which is dynamics, or they are stable, which is called statics. So at first we will talk about dynamics. So what is dynamics? Okay, I understood the definition, but I don't understand what you are saying. Well, I answer that by this beautiful example. If I have a ball moving with a velocity like 6 meters per second, and I have a ball here, I have a floor here, just called F, and the ball is moving with acceleration 9.81 meters per second squared. And the distance between the starting point of the ball and the floor is, let's say, like 12 meters per second. So, of course, I want to calculate the time needed by the ball to reach the floor or the point F. So, simply, that's dynamics. Of course, dynamics, I have a moving object. So, as the object moves, it has speed and covers a distance. But what causes this object to move or the ball to move? It is under a resultant force. So, what is a resultant force? Considering this ball is moving, it has a weight, this is the weight, which pulls the ball downwards as it falls from up to down. Like I will leave this pen. So this pen moves down, so this ball has a weight. So I will throw or leave the ball. So its weight pushes it or pulls it downwards till it reaches the ground. So there is a resultant force acting on this ball. So what if I don't have a resultant force acting on the ball? This is called statics. Statics is just the ball is like that. It's stable, it doesn't move, either right, left, up and down. Okay. The ball is called at equilibrium. Equilibrium. So this equilibrium can be reached like two different ways. When the ball is stable, as it doesn't move, like it's stable, it doesn't move, it doesn't have a velocity. Okay, so what's the next case? When the ball is moving at a constant speed. So you might freak out right now, as I said before in this video, that dynamics is a study of a moving object. But statics also can be a study of a moving object, but in a certain condition that it is under a constant speed. So if I have a ball like this, okay, this ball, let's draw this vector diagram, the forces diagram, okay, I have a force like that, and the friction against the ball. So the ball now has a speed of 0. So I begin pushing the ball like this. So the ball starts gaining speed. Now the ball has speed, like velocity equal, let's say, 2 meters per second. Now the friction has increased to equalize the force I produced to let the ball move. So the ball will not accelerate, or the resultant force equals 0, like F minus friction equals 0. So at first, when the F was larger than the friction, the ball started to move and accelerating and gaining speed. Okay, this was an absolutely dynamics case. Simple. But when the friction and the force F that I produce now are equal, so the ball is considered to be at equilibrium, as it is moving with velocity like 2. It won't accelerate, as the resultant force acting on the ball equals 0. Resultant force equal 0. So no resultant force. So this is the case that the ball is in a static position while it is moving. The only case that the resultant force equals to 0. Okay, thank you for watching. I will be starting the static course in the next videos, which includes resultant of a force and vector of forces, equilibrium of particle, equilibrium of rigid body, trusses, frames, friction, and last but not least, rolling, toppling, and slide. Please subscribe to my channel to get the new videos as fast as I upload them. Thank you for watching.